All right.
Great. Actually, Ryan, if I can just ask you to give a quick intro of yourself, we're going to do that first thing just to welcome everyone.
Yeah, my apologies. So my name is Ryan Peak. I am currently a postdoc at UC Davis at the Center for Watershed Sciences. And I've been really enjoying teaching R to as many people who will listen.
Thanks. Hi, everyone. I'm Haley. I'm the co-host today. I'm a scientist at the Southern California Coastal Water Research Project based out of Costa Mesa. And I'm in the biology department, but really sort of the data visualization and anything data science related guru there. And then if we could have all of our helpers, kind of like yesterday, just give a quick intro of yourself so folks can see who you are when they message you.
Hey everyone, I'm Anna. I'm a PhD student at UC Santa Barbara studying ecology.
Hi everybody, I'm also Anna, sorry Martha. I am also at UC Santa Barbara studying ecology.
Hi, I'm Martha. I'm at UC Davis studying ecology.
Hi, I'm Christine. I'm a PhD student at UC Davis studying food webs in mountain lakes.
Hi, I'm Anne. I'm a PhD student at UCSB studying ecology.
Hi, I'm Caroline. I'm also a PhD student at UCSB studying ecology.
All right, I think we got everyone. So we've got their names there in the chat, and feel free at any point to either post a question to everyone in the chat or message any of our helpers directly. They'd be happy to help you out with whatever you might be struggling with. Also, just some quick housekeeping. We're happy to have you keep your cameras on if you'd like to during the meeting, but we ask that all the participants mute themselves for the duration of the meeting, just so we can sort of keep the flow of things going. And a couple times throughout today's lesson, we might be just taking a quick status update. So if everyone can take a look and make sure that they have access to the little green check mark and the little red X in the Zoom window. So if folks see that, could you please check the green check mark, yes, to show that, that you're able to access that button. And if you're having trouble locating it, again, feel free to ask one of our helpers. So we'll be occasionally just taking a quick, taking the pulse of everyone to make sure that folks are following along. And if you're really struggling at any point in the lesson, even if we haven't prompted you to, please feel free to use the red X, and our helpers will come help you. They'll come find you and be looking for that. Okay, great. So I'm going to go ahead and clear those out. And then next thing I wanted to do, I'm going to go ahead and share my screen and just orient you briefly to the website. So if you happen to be following along, can folks see? Let me make sure that I've got. Can folks see my website currently up on the screen? Okay, great. Just wanted to make sure. Sorry, just setting up my chat and participants here. So if you navigate to the website, you'll see we have some wonderful illustrations by Alison Horst. So a big thank you to her for helping contribute those. And if you're interested, you happened to miss yesterday or just want to go back on something, if you scroll down on the homepage here, Ryan has added the link to YouTube for our recording from yesterday's lesson. So feel free to go back to that at any point. And then I also just wanted to orient you to a couple of resources here in case you fall behind or have a question about something. So on the website at the top, you'll notice there's a resources tab. If you navigate to that, we will have all of our code posted here. So as we're coding, we'll be uploading it to a Dropbox file and saving it as we go. So if you happen to fall behind or get lost or just can't make it out on our screen, in day 2, if you click on this link here, you'll actually be able to see all the code that we'll be coding. In addition, I just wanted to orient everyone to the data that they might need for this lesson is in this lesson data sets So you can either download them from here, or they'll also be sort of sprinkled throughout the lessons. But just wanted to let you know that this is a sort of central location for them as well. And then let's see. I think that's all I had to do on the website. Ryan, did you have any additions before I sort of launch into the actual coding? Okay, great.
I think that's good. Yeah.
Great. Okay, so for the first part of today, I'm going to be working through this Excel to map lesson set here, so the one with the little car. And just so you're oriented, I'm going to do a very brief lecture based on the website, and then we'll sort of shift gears and move into RStudio in both days. So if you all want to follow along on your own screens, you can, or you can just sit back and watch for just a couple minutes. And today, sort of continuing our data wrangling and manipulation themes that we were working on last workshop. Today we're going to be doing some more data wrangling. So today we're going to be working from Excel spreadsheets instead of just CSVs. And then we're also going to be doing some more advanced and exciting visualization and mapping as well. So the first thing I wanted to cover with everyone today is the concept of tidy data. So just so everybody has a good idea as to what it is, and this is sort of the gold standard or the ideal format that your data should be in, is a variable in each column, an individual observation in each row, and then within each cell of a given data set, you have a single measurement. So if you look at this example, I think it's just a data frame of cats. We have every variable forms a different column. So we have ID, names of the cats, and the colors of the cats. And then each observation is a different row. So we have a different cat in every single row. And then every single cell is a different measurement. So we have individual unique ID numbers, all the cat's names, and then we also have their coat colors in a different column. So this is, as I mentioned, sort of the gold standard or ideal format that you want to have your data in, and it makes it easiest to work with in R. And today we're just going to look at data that is and isn't tidy and talk about how to essentially work between those two formats. So if you scroll down, we have an example of what a untidy or somewhat messy data set might look like. And as you'll see, you might have a number of tables, you might even have figures in a given tab. Here we're working in Excel spreadsheet, so it's not even just in a single tab, it's across multiple tabs. And that's fine. I'm sure all of you have encountered data sets like this. So we're going to hopefully provide you with some tools today to approach these data sets and wrangle them into a more usable format. All right, so I'm going to go ahead and move to RStudio now. So if everyone wants to go ahead and open up their RStudio. And if anything doesn't open properly or something's not working, again, please feel free to submit a question in the Zoom chat. But just to orient you all, my console here is on the left-hand side. I've got my environment up on the upper right-hand side, and all my files and whatnot are in the bottom right-hand corner. So if your screen looks a little bit different, your layout's a little different, that's fine. But that's how mine's currently set up. And before we get started, I did just want to sort of go over a couple tricks when you're getting organized to make future you and any of your future collaborators happiest. So the first thing we're going to do is go up into RStudio. I'm working on a Mac here, so it might look a little different than some of yours. But if you navigate to Preferences in RStudio, the first thing we want to do is in this workspace, so we're in General Options. In Workspace, you want to make sure that this Restore R Data is unchecked and you are never saving the R data when you exit. This is just good practice so that every time you open up R, you're opening up a fresh, clean slate and making sure that things are reproducible for yourself in the future and for your collaborators. So you're making sure that you're sort of starting from a fresh, clean slate at the start of every single workflow that you're doing. All right, so sure that's good to go. And then the next thing we're going to do, for those of you that joined us yesterday, you might already have an R project started, which is great. So if you worked with us yesterday, I would say navigate to that R project. If you didn't work with us yesterday, go ahead and start a new project. So you can do File, New Project. And essentially what we're going to be doing is building all of our files into one same working directory. So you can go ahead and create this directory, and it's just simply going to be a new project. And I would name it something memorable, and then also make sure that you place it somewhere memorable. So most of my code, I have a GitHub account, so I put all my code into a GitHub folder. It can go wherever you like. Just make sure that it's going to be somewhere on your computer that you can get back to easily and remember where it is. So again, feel free to name it whatever you like. You can name it CABW Workshop. If you have the project from yesterday up and running, great, just sit tight. But just make sure that you, again, put it in a place that you'll remember. All right, so I'm gonna go ahead and cancel out of here because I already am in my project. But once you create that project, you should just, it should open up in a brand new RStudio window. And the first thing we're gonna do is just create a new script that we'll be working out of today. So for everyone who joined us yesterday, let's go ahead and make a new script for today. So File, New R script. And let's add in a first comment for today's title. So we'll say CABW Workshop Day 2. I would always make sure to add in your name and the date as well. And then once you go to save it, do File, Save As. And here, make sure that you're within your project that you just created. So mine is a 2020 CIBW. And here, before you save your script, I would set up 2 separate folders. So you can create new folders. One of which is going to be your code folder. That's where you'll save the script. And another one that'll be your data folder. So that's where you'll be saving your data for this particular lesson. And once you've created those 2 folders, go ahead and save your script into your code folder. Again, we're just keeping things organized from the get-go. It's a good habit to get into, and future you will thank you. So I'm going to go ahead and open up, this is my script here. So you should have your script with a nice working title, perhaps today's date, your name, and everything, again, that I'm typing here in my script will be uploaded on that Dropbox file. So if you're having trouble navigating it, or if you aren't able to see it, please let one of the helpers know and they can help you out. All right. So here we have the website in case anyone is in need of that. And I also just wanted to start off today, we'll be using a couple of different shortcuts. So I wanted to provide them here and also provide you with a link on how to see those. So a few things to keep in mind, make sure as we're typing, R is always case sensitive. And if you're having trouble navigating any of the shortcuts, you can always press Shift-Alt-K, and it should bring up all of the available shortcuts in R. You won't have to memorize these, don't worry. We have just put a couple of the key ones here. So on the run shortcut on PCs and Macs, as well as the piping shortcut, both of which will likely come in handy later today. All right, so before we start coding, I just want to make sure everybody has the first data set that we'll be working with today. And so that data set is available on the website in the messy data set section. So if you go ahead and download this Excel file and save it into that data folder that you created in your brand new R project. I'm going to give folks just a moment to do that. And if you're having trouble downloading and saving the data to the correct location, again, please feel free to message any of our helpers to help you do that. again, don't panic that the first tab is a little bit messy. That's on purpose. All right. So, so I'm gonna navigate here. So here are my files in my project. I've got my code folder, my data folder, and when I click on my data folder, the CSCI spreadsheet that you all downloaded is in there. So your code should look, or your, excuse me, your files should look something like that. If they don't, let Ryan or one of the helpers know, and they can make sure you get your data routed to the right place. All right. So working in our code here, I'm going to go ahead and insert a new section just to keep things organized. So we can go to code, insert section, and let's call this spreadsheet madness to tidy data. Fantastic. And the nice part about this too is you can navigate through your code using these sections. So if you go to this little upper right-hand corner here, you've got a table of contents, and you can actually navigate to different parts of your code based on these sections that you insert. So this is really nice if your code starts to get a little unwieldy. All right, and so the first thing we need to do is load the packages that we need to use today. So we load in our packages using the library function. And the first we'll be using is the tidyverse. The second we'll be using is called OpenXLSX. This helps us load our Excel files. And then the third, another one to help us create and read in Excel files, is this Read Excel. If any of you haven't yet installed these, remember you can install these in your console. I would not recommend installing them in your code because it only needs to happen once. You can use it, use the install packages function to install. And remember, you have to put quotes around all the packages you're installing. So if you haven't done this yet, you can just use this function. But let's go ahead and run this, these packages here. So again, you can either run it using this run button at the top, or you can use the shortcut up here. That's either Control Enter or Command Enter is fine. All right, and now that we've got our packages, let's go ahead and load our data. So we're just going to call this messy, because that's what it is. And in order to read in an Excel file, it's going to look a little different than yesterday. So we're going to say read Excel, that's calling the actual package. And then read underscore Excel, that's calling the function. And you want to put in the path where the data is coming from. So in this case, it's going to be in my data folder, and it's called CSCI spreadsheet XLSX. And in this case, we're only going to read in the first sheet because we're just assigning that first tab to messy. So if you go ahead and run that, you should see it pop up in your environment. And there's two ways to examine the data. You can either type view messy here in your script, or you can simply click on it in the environment. But either one should bring up a new tab that looks somewhat like an Excel spreadsheet. And right away, you can see we've got some problems. So our column names are a series of gibberish numbers and periods. We're missing a row. This is like already giving me heart palpitations. And all of our column headings are in a row unto themselves. So this clearly has some problems. Oh, and then we transition into column names later in the data set. Okay, so this kind of data set is very challenging to work with. And you can immediately see that ours also already having issues. So let's go ahead and read in the other sheets and take a look to see what they look like. So let's read in sheet 2 and assign to object named CSCI. So we're going to call this instead CSCI. And if you want to, you can go ahead and just copy paste. I'm going to go ahead and type it just so it takes me a moment. Data CSCI spreadsheet. And in this case, we're going to do sheet 2. So it should look very similar to what you had above, except we're assigning it to CSCI and reading in the second sheet instead. So let's go ahead, take a look at CSCI. Whew, and already it's looking a lot nicer. So we can see that it recognized that all of the column headers should be in their own row here. And then each of our values look good. We don't have any sort of gaping row of NAs or some sort of weird transition like we were getting with the messy data set. So things are looking pretty good here. And so let's go ahead and then read in sheet 3 and assign to object named sites. So again, your path names might look a little different than mine. That's fine. But just so you know where your code is and where your data sets are, making sure to keep those organized as you work through your workflow here. All right, so here we're reading in sheet 3, assigning it to the data frame named sites. And if you go ahead and run that line, again, should show up in your environment. So you've loaded that in appropriately. And if we want to take a look, this is also looking pretty good. So it's a much smaller data set. We've only got our latitude, longitude, and station IDs in this case. And things are looking pretty nice.
Haley, would you mind saving your code, please?
Sure. All right. Are there any questions? Feel free to post those in the chat, or if anyone's having any difficulty reading in any of those data sets. Remember, errors are totally normal, totally okay. Still happens to everybody, and 9 times out of 10, it's just a misplaced comma or parentheses. So don't feel silly about that. That's very normal. Okay, and then I just wanted to provide you with a couple fun functions to examine your data set. So if you just want to take a quick glimpse at the data set, you can actually use glimpse. And let's say we just want to look at sites. So when we run glimpse for our sites data set, you'll notice down in the console here, we get a quick summary of the number of rows. So there's about 1,600 individual observations. We got 3 different columns. And then it also provides us with the data format for each of those. So our station ID is recognized as a character string, which makes sense. And then both our latitude and longitude data sets are recognized as double, otherwise known as numeric. So that's also good. Another nice function that you can use to examine just the top few rows of a data set is head. So if you run head, also for that sites data set, you'll notice it gives out approximately 6 top rows of your data set, again in the console. And it's just a slightly different way of looking at your data, but we still see our 3 different columns. Again, it gives you their format, so character, double, double, and then the top 6 rows, just to example. And then another helpful tool for examining the structure of a data set. So just seeing what format your data is in, you can use str. So let's do this for CSCI instead. And if you run that, you'll notice in the console that it will print out the size of your data set. So you'll have 1,600 by 8, it looks like. And then it'll also list all of the individual columns, followed by what their format is, and it'll spit out the first couple iterations of it as well. So here we can see in the CSCI data set, we have a much more varied data structure. So we have sample IDs and station codes that are read in as characters, and then we have a whole suite of indices that are read in as numeric. That's what that in. Great. All right, and a particularly powerful and quick assessment of anything that is numeric, date, or factor. Data classes. You can use the summary function. So let's say we want to do a summary of the CSCI data set and look at 7. All right, so what this is doing is it's taking a summary of our CSCI data set, and when you're referring to things within brackets, you put rows first, comma, and then columns later. So we're interested in looking at the C is just presenting a list of the columns that we're interested in. So if we're interested in columns 3 through 7, we're going to put those here. And what you're doing is basically generating summary statistics for columns 3 through 7 in your CSCI data set. So when you go ahead and run that in your console, it'll print out a whole lot of summary statistics. And this is really helpful when you're just trying to get a feel for what your data spread looks like and what sorts of mins and maxes you might be looking at. It also provides medians and quantiles, a lot of the information that you might otherwise get from a box plot as well. So this is particularly helpful, but just keep in mind it does only apply to certain data classes. All right, and so one of the other helpful tidying steps that we sometimes do in the sort of data tidying is, let's say we want to remove NAs. So let's go ahead and drop NAs from the data set. And to do this, we'll be using something, an operation using an exclamation point, which translates as not. So you'll see how this works in just a second. So let's say we want to drop all the NAs from the CSCI data set. So let's create a new data set called CSCI clean. And then we're going to use in the dplyr package, we're going to use the filter function. So some of you might recognize this from yesterday. So in filter, because we're using it in just a single line, we're not doing any sort of piping here just yet. Remember, we have to specify what data set it's calling from. So we're going to call from the CSCI data set. And we're going to use our exclamation point is.na and then refer to the CSCI column. So what we're doing here is we're filtering the CSCI data set, and we're dropping the NAs from the CSCI column. So if you go ahead and run that, it should appear up here in your environment. And if you look at the dimensions, so we'll say examine dimensions of data set, we can use DIM, the handy function for just looking at the size of the data set. So if you run dimensions on this new data set, CSCI clean, that we just created, you can see the dimensions are 1,612 rows and 8 columns. So already we can see that we dropped only one observation, because that CSCI data set we were working with previously was 1,613 rows, and now we're just down to 1,612. So we really haven't lost all that many rows, which is kind of nice. But we've removed the NAs, which could cause problems later down the line. All right, and then for additional tidying, let's say we want to simplify some of our column names as well. Specifically in our sites data set. So we'll create a new data set called sites clean. And again, turn to our handy dplyr package, and this time use the rename function. So again, some of you might recognize this from yesterday. And let's go ahead and give it the data set. Lat equals new lat. Long equals new long. So remember, in the rename function, it takes the new name of the column first, and the old name of the column second. So it's a little funky like that. And go ahead and run that. Whoops. All right. So what we've done here, whoops, we used the wrong data set. So we were trying to create a new clean sites data set, but we accidentally referenced the CSCI data set. And so it wasn't able to process it because the new lat column doesn't exist in the CSCI data set. All right, so let's try that again. So now, sites clean. So now, let's go ahead and use the correct data set. So here we're going to do sites. And again, lat is going to be the new name. New lat is the old. Long is the new name. New long is the old. And if you go ahead and run that, that should work. So just a reminder, error messages, totally normal. It's going to happen all the time. Don't panic. It's totally okay. Great. So then if you go ahead and we can just use one of our fun functions that we learned earlier. So let's examine the new data set. Let's use head to look at this new data set that we just created. And if you do that, you'll get your little handy printout in the console, and you can see that our column names changed. So it did exactly what we needed it to do. And lat and long are just a little bit easier to type out. So when we reference them in future code chunks, it's just going to be less to type. So it'll be nice, nice and easy to remember. So I'm just going to pause here for a second, see if there are any questions. Feel free to post them in the chat or message one of our helpers directly. All right, so now we've imported our data sets, some of which were tidier than others, and we've tidied the ones that were useful to us. So we've done some renaming and simplifying. So let's say now that we've done all this transformation, we actually just want to export them. So we can either send them to collaborators or use them in another program. How do we go about doing that in R? So here are a few different ways to export your tidied data sets. All right, so the first way we'll go over is how to export as a CSV, which might be what you use most often. So in order to do that, we'll just do read R. That's the package that we'll be using. And within that package, we'll be using the write_CSV function. And let's first do CSCI clean, since that's our tidied version. And we're going to send it to our handy data folder. And we're just going to call it the same name, CSCI_clean. So we're referencing the data set that we created at the beginning here, CSCI_clean. And then in the path part, that's where you're actually naming the file that's going to be exported. So if you go ahead and run that line, you might see your CSV. If you've got your files open in the bottom right-hand corner, you might see your CSV pop up in your data file, which is great. That's where it's supposed to be. So let's go ahead and do the same, write_CSV for our sites data set. And again, just for clarity's sake, I'm going to go ahead and keep all the names the same. So once you've exported these, if you wanted to one day import these data sets back in, all you have to do to read back into R is use read_CSV. So the export function is write_CSV, and the reading back in is read_CSV. All right, so let's say you're interested in exporting it as an RDA file. So what's an RDA file? An RDA file is basically a file that is R specific, but the nice thing is it maintains your data structure. So if you specified something to be a factor or a character or numeric, it'll remember that. And the nice thing about RDAs is it also can include multiple data sets. So this can be very handy. So in order to do that, since we can do everything at once, it can do multiple data sets, we're simply going to do save CSCI_clean, as well as our sites_clean. And we're going to save it to a single file, which again, we're going to send to our data folder. And here, I'm just going to sort of squish the names together. So we'll do CSCI_sites_clean. And here, the suffix is going to be .rda instead of .csv. And if you run that, should again pop up in your data folder here. It's just going to look a little different. It's got this cute little R symbol. And that just means it's an R recognizable file format. So when you want to read back into R using this RDA file, all you have to do is use load. That's the function that you'll use. There's also an alternative to export as an RDS. Again, this is an R recognized format, so it will maintain your data structure. But in this case, it's only one data set. So if this is something you prefer to do, that's fine. So this is going to be, instead of save, it's going to be save RDS is the function. And we're going to do these separately since it can only save one at a time. So it'll be CSCI_clean. And you simply supply a similar file structure. And here, instead of .rda, it's going to be .rds. And let's go ahead and do the same thing for sites. File equals data sites_clean.rds. So if you run those, you should see CSCI clean and sites clean. Instead of popping up as CSVs, which we did earlier, they're going to be recognized as RDS files, separate R recognizable but unique files in your data folder. And the way that we read these back into R is using read RDS. All right, so the last format, in case you want to go back to Excel, having come originally from Excel, maybe it's what your collaborators are going to recognize most, export as an XLSX. Requires a couple more steps, so just follow along here. We first need to create a blank workbook. So that's what this create workbook function does. So say first create blank workbook. And after you create the workbook, then we're actually going to load in each of the data sets. So we'll say create the worksheets. So we'll do add worksheet in our workbook. Oops, sorry, a lot of suggestions. So the first name, we'll put in the first sheet name is going to be CSCI_clean to match our data set. And we'll also just specify grid lines true. That just helps us in formatting. And then we need to set up a second worksheet. And in this case, it'll be sheet name sites clean. Again, grid lines equals true. All right. So if you run both of those, now we've created a blank workbook with two sheets readily named, but they don't yet contain the data. So we need to add our cleaned data. So let's go ahead and write data table. And we're going to tell it where it's going. So we've just used the default name, WB. And in the first sheet, so sheet number 1, we are adding CSCI clean. And we are not filtering the data in any way as we added it. So we're going to do the same thing for, again, you can copy paste if you like. I just like to type these out as I go so I know exactly what I'm doing. So in our second sheet, this time we're going to specify sites are clean and with filter is false. All right, so we've created the blank workbook. We've created 2 blank but named sheets. And now we've added our data to those sheets. Okay, so now it exists, but we haven't yet exported it. So now to export our data. So in order to do this, all we say is save workbook. And we're going to save our workbook WB and save it to our path that we've specified. So in the data folder, let's again name it CSCI sites clean. And I'm just going to call this spreadsheet so we can differentiate it. And overwrite equals true. All right, so if you go ahead and run that line, in your data folder, you should now have a new XLSX spreadsheet that appears that only contains those 2 tabs of tidied data that you've just created. And just as a reminder, if you wanted to read this back into R, you can do so using read Excel, which is the package, and then these 2 little colons just call the particular function read underscore Excel that you'll use to re-import this data set. All right, so I'm going to take a quick break here before we move to the next lesson and see if there's any additional questions. If everyone's doing okay up until this point, please give us a green check mark. If anybody's really struggling or one of your exports isn't working for some reason, please give us a red X. Just give us a quick status update on how you're doing. All right, so it looks like we've got a good number of green checks. Awesome. So what we've done here is we've learned how to import a new data format, well, different from the CSVs that we were using yesterday, but I'm sure many of you are familiar with Excel, and done some additional tidying. But let's say that there is some joining that you want to do. So you've got 2 data sets that you want to put together, but you're not entirely sure how to do so. So I'm going to just bring up the website. If you'd like to follow along on the website, feel free to, or you can just sit back and take a look at my screen. So here, if you go to lesson 2 in joining data, I just wanted to walk through a couple different ways that R has for joining your data, and they're all pretty handy. So in this video here, you'll see one of our first options here to join data together is known as a left join. So you're sort of using the first data set, or the X here is the primary data set, and anything in your secondary data set that matches gets joined together. So it recognizes everything in data set X and then looks for it in data set Y. Another option is known as the inner join. which is, again, comparing between two data sets, X and Y. But what an inner join is doing is looking for commonalities between those two based on this initial column. So anything that doesn't match up between these two data sets, so in this case, the 3 and the 4, those are dropped from that join. Say you want to keep everything, so every single observation, even if you aren't able to match things up, you can do what's known as a full join. So it'll join by this first column, but keep every single observation in both data sets X and data sets Y. So if you don't want to lose a single thing from the data sets that you're joining together, you can use a full join. You can also use what's known as a semi-join. So here, you're simply joining together again data sets X and Y, but you're only keeping columns from X where there are matching values in the Y. So again, we're dropping 3 and 4 here. And then finally, the anti-join is also known as a filtering join. So this is where you're comparing data sets X and Y, but you're actually only keeping those values in X that don't match anything in Y. So again, the priority data set in this case is X, and all that's being kept is basically non-matches. That's why it's the anti-join. So all you're left with in this case is 3 in this example. So I realize in the abstract, some of this can be a little bit confusing. So let's go ahead and practice this with one of our own data sets, and you can get a feel for how these joins actually work. So if we're back in our RStudio here, let's go ahead and insert a new section. And I'm going to call this joining data sets. First thing we need to do is load necessary packages. So for this section, make sure that you've got your dplyr package loaded. It may have already loaded in your tidyverse, but just to be certain it's loaded. And let's say we're interested in joining those two data sets that we just created. So our CSCI clean and our sites clean, we want to join them together into a single data set. So join data, and they need to have a common column. And what's more, this column should have the same name in both data sets. So let's say we're going to create a new data set called CSCI underscore sites underscore match. So we're just pulling together that CSCI clean and sites clean. And we're going to match them by stations where the samplings actually occur. So we're going to use that inner join function. We're only going to keep the ones that are in common and pull together our CSCI clean and our sites clean data sets. All right, so if you go ahead and run that, you'll notice in your console you get an error. And it says that X and Y have no common variables. So basically it's looking for a common column, and more specifically, it's looking for identical names. So we know in both our CSCI and our site data sets, we have station IDs, but they're actually named a little bit differently. So we need to tell R that in order for it to be able to join the data together. So let's say join data by common column, different name. So here, we're actually going to specify what it's going to join by. So let's try this again. CSCI sites match. Again, we're going to do this inner join. CSCI clean and sites clean are going to be our data sets that we're joining. But now we're going to do it by, so I've just pressed enter here to get myself onto a new line just to kind of keep things straight. So by lets us tell it station code is the name of the column in CSCI clean, and station ID is the name of the column in sites clean. So keep in mind, when we were looking at those examples, there was an X and Y data set. So here our X data set is CSCI clean, or the sort of primary data set. And then sites clean is the Y data set. So that's the one that we're joining with the first data set. So when you're here specifying the column names, they also need to follow that same ordering, that same format, so that station code is referring to a column in CSCI clean, and station ID is referring to a column in sites clean. So here, I'm just going to add a little note here. Remember the X column first. All right, so if you go ahead and run that, we should have a new data set. So let's examine the data set structure. So remember, we've got that handy function str where we can look at the data set structure. And if we do that, it should print out in your console where we now have a data frame with 1,612 rows and 10 columns. And as you scroll down, you'll notice that the lat and the long columns have been added on to the end of that data set, which means that it's been successfully joined using those column names that we gave it a row above. All right, and just to take a look, let's look at sites that didn't match up using anti-join. So this is sort of like the mismatch function, essentially. So anti-join, let's take a look at sites clean and CSCI clean. And again, we need to specify station ID, station code. And if you go ahead and run that, since we didn't assign it a name, we didn't assign it to a new data set, it'll just print out in your console. That's fine. And we just had the single observation that didn't match in our main join. All right, so before we take a break in between lessons, real quick, let's go ahead and save out this newly joined beautiful and tidy data set that we've created. So save the data out. And let's go ahead and save it as an RDA file. So remember, that's one of those R recognized data frames. And it's just going to be a little bit easier to bring it back in. So we'll do save CSCI sites match. So that's that data set that we created using our inner join up here. And we're going to save it to our same data path. I'm just going to use the same name. Keep in mind the file extension here is .rda for RDA files. So I'm just going to add here, save the data out as an .rda. All right. So looks like we are right on time. It's 3:15. I'm going to turn it over to Ryan. Before he starts, though, we're just going to give everyone a quick 5-minute break. So I'm going to go ahead and stop sharing my screen. But if you need to catch up on the code in any way, feel free to visit the website, and it should be up there.
Awesome. Thanks, Haley. So 5 minutes. So we will start right at 3:20. Okay. So get up, stretch, or ask some questions, whatever you would like to do with 5 minutes. Please take that time, and we'll be right back. We'll start our recording again. Okay, so that was great. That was a lot. I know we are covering a lot of ground. I will say that all the things we're covering from yesterday, where we're reading a CSV of things in, working with different tools, to today we're working with Excel, and then we're going to move into actually working with some spatial data and saving spatial data out. That you know, you are going to actually have a majority of the sort of different data formats that you can work with in R and know how to get them in and out, which is honestly the biggest part of the battle. So anyway, I'm going to pick up where Haley left off. And one thing that I would like everybody to do, just to make sure, is I want you all to go into your participants, and I will awkwardly wait until you have done so, and just hit a green yes that you are ready to go to move into the next section, and you have RStudio open, just to make sure everybody's still with me. I know it's towards the end of the day, and my household has multiple Zoom calls going right now, so you might have some background noise. I apologize. So still have some folks that haven't done the green check. So if you can go into the participant list and do a green check, that would be awesome. Getting close, getting close. Great. All right. That is pretty good. I'm going to go ahead and move forward. So along the lines of clean data and tidy data, and sort of keeping just having a good set of habits for how we work in R. Pretty much in between each of these lessons, we haven't necessarily been doing it, but think about this as if you're going to work on something, you should really be sort of restarting R fresh with a clean slate. Remember when Haley showed everybody how to turn off the save workspace? Same concept here. I'd like everybody to go to session and go ahead and go to restart R. And this seems daunting, but you should get in the habit of doing it. Often it'll solve problems that you are having. But more importantly, it should end up with a clean environment. I have nothing now in my global environment. I have this one function, but that's something I've put in there I should have removed. But so everything is gone now, right? We have a clean slate. And so imagine we are now in, ideally we kind of break these into different scripts, right? So we make a new script. For today, I'd say let's just use whatever you've got, and you have that open. And so I'm going to make a new section, and this is going to be working with the SF package. Okay. So once we've done that, now we can now we're starting fresh again. Again, I'm working in my script up here. I've got my console down here, trying to match Haley's setup today and the default setup in R. And so what you're going to want to do first whenever we start these things is we want to load our packages, right? So what are the libraries that we're going to use today moving forward? Let's load those up. We're going to use tidyverse. And we are going to use the, for now, let's just do SF, tidyverse, and map view. Oh, and Viridis. If you haven't, Viridis is a color package, which is really handy. It has a whole bunch of color palettes that are friendly for folks who have all kinds of different sort of what colors they can see. So it's a good package to have handy, particularly for making maps and plots. Okay, so these are the main 4 packages. I know there might be another 1 or 2 listed there. For now, let's just load these. And one of the things that may happen is particularly when you load the SF package. So when I run that, I'm hitting Control Enter, by the way, or Command Enter along each of these lines, or you can click the Run button up here on the line that I'm on. So if I click Run, it's running that line. So one of the things you'll see for the SF package down here, hopefully y'all can see that, it's going to give this sort of string of all kinds of information about geos, GDOL, proj, and have some numbers. I will say one of the biggest hurdles is you might get some errors associated with installing spatial packages in R. Once you have everything installed, it's really amazing what we can do now in R for spatial analysis. So anyway, just as a heads up, okay, so now I've run these 4 packages that we're going to use for the rest of today. And just to let everybody know where I am, we are now on, hang on one second, because I've got a lot of windows open here. We are on the website. Okay, we are essentially working off of, in the car, I'm now going to this lesson using SF. Okay, so what I'm going to cover in the next, hopefully 20-25 minutes is essentially how to make our, we have this data with lat and long information, but we want to now make that spatial so that we can make maps out of it. And then also, what are some of the things we can do with the SF package, including working with different spatial formats. So shapefiles, for those of you that are familiar with those, KML or GPX or GeoJSON, all of those are different types of spatial data. And no worries, if you've never heard of those before, we're going to go through that. So one of the first things that I want to point out, which is SF, is the simple features package. It's really, I would say, I wouldn't shy away from using the word revolutionized, because it's really changed immensely how and what we can do in R with spatial data. And that's because of this awesome cartoon that Alison Horst, again, has created, which really gets to the root of why SF is really powerful. So at the root of all spatial data, we have some sort of attributes, right? So if you're familiar with shapefiles, there's a table with attributes on, say, like for bioassessment data, where that site is, what the site name is, the date that we collected things, who collected it, all those different things, right? But then there's a whole separate sort of file system that's associated with the spatial components. And what's really ingenious about the SF format, or simple features is what SF stands for, is that it sort of keeps all those attributes, this table here, right? That's all our data that are just our data frame that we would be using normally. But then it adds a geometries column. So there's literally a column that will get stuck next to whatever SF data frame we have. And it's sticky in the sense that it keeps all the spatial information. So it has show these little polygons, right? And essentially it's all crammed into this one column. And I'll show you what it looks like in a second. But what's really awesome about this is that this sticks with this table no matter what you do to it. So all the things we've talked about with joins and dplyr yesterday and filtering, a lot of the really powerful things that you can do to clean data and analyze data in R, now you can do it and keep that spatial information with the data set, which is great because then you can just spit a map out really quickly. So that's why the SF packages, I think, really changed how we do things and made it really possible to do some pretty cool stuff. So, so again, we're on this lesson here. I'm going to jump back over to my code. And so we have this. So now I'm going to make another section, Control-Shift-R, import data. And we're going to, the data that we saved literally from the last lesson, we're going to bring that back in with load, and we're going to load is for the R data file, the RDA file. And the advantage of this is that it retains all the formatting, so we don't have to do anything really once we bring it in. It's already good to go. So CSCI sites, I'm using tab autocomplete here. Again, it saves on typos, which R is sensitive to. And then it allows you to find, if you don't find it, then that probably means it's not where you think it is. So data and sites clean.rda. Okay. And then I'm going to run that line, Control Enter. Great. So now over here in my environment, I've got two different objects. I have CSCI clean and I have sites clean. And notice there's one more observation in my sites than there are in my CSCI. And there are 8 columns here and 3 columns here. And so that's a quick way to kind of inspect your data, right? Like, okay, what do we have? All right, awesome. So now let's go ahead and jump over to hang on one second. Let me save this. So now let's take a look at our data, kind of what I was doing right here, but you can actually use some different functions we've talked about yesterday briefly, but summary of our CSCI sites match. Oh, so I have loaded the wrong data set. So notice I was talking instead of looking. I have something called clean. I don't have the thing called match. But what's really cool is Haley has all the code up here that you all just ran. So I'm gonna go, I'm gonna go quickly run through this code and rerun it. Whoa, which is the advantage of scripting, right? So the cool thing is if something happens like this and you restart, you can usually pretty quickly run through all this code, and I could highlight all of it and run things, but site's clean. Always things on the fly. Hang on one second. Let's find in our files and our data. Maybe this is the same thing. So I'm going to say this is CI's clean. On the website, I think it's probably match. So I apologize. This will be easier than rerunning everything on the fly. Site's clean. Hang on. There we go. Okay, so welcome to coding, right? So that is just par for the course. I apologize. All right, so moving forward, hopefully, one of the things we want to do is take this data set and make it spatial. And when I talk about making something spatial, what I mean is we want to take that essentially the lat long information here. And actually, I think I'm going to have to go back and get this data set because we are going to need it. So a green, actually, can everybody put a green check if you were able to read in this CSCI sites match, or if we're all sort of in the same boat that I am. So if you have a chance, can you go into your participant list and put a green so we can follow up? And I'm going to troubleshoot this real quick to make sure that I have the stuff that I need. Okay.
Hey, Ryan, I think you should be good just to hop in. If you just rerun the joining data set section, the reason you were getting that error is just because you hadn't specified the first one, we didn't specify the columns, which was kind of on purpose. And so the second one where it says match it by station code and station ID should be good to go.
Great.
And then, yeah, and then save it out. Should be good.
Did this get saved in our data folder? No, or at least hasn't shown up for me, which is has to do with the vagaries of Haley and I are sharing a Dropbox thing, so it may not have updated yet, which is just how the.
I think it just popped up.
Awesome. I just ran it, so okay. All right, so I'm going to do a session restart. You do not have to do that if you have all done, hopefully following with what Haley did, and then we should be back to something that is functional again. And so in my environment here, this is good practice. This is kind of how this works. Again, the more you can restart and rerun your code and get in the habit of that and not freak out, the better off you will be. So sites clean is what we have, but again, we didn't have the joined data here, I think. For some reason, this did not save the piece that I'm interested in. There we go. Match. Okay. Thanks, everybody. Okay, so now we have our CSCI sites match, and we can move forward. Thanks for bearing with me here. So now we can summarize our data. Okay, we got everything. So now the next step. So let's talk about how do we make our data spatial, right? And I think this is kind of one of the harder parts of working with spatial data. And so one of the reasons I point out to inspect the data is particularly when we're working with lat-long data down here. The longitude, at least in California where we live, everything is typically negative. And a really common error that happens is you'll have a, one of these just gets misentered or it's wrong. And so you might have a positive longitude. And so when you plot that, it ends up somewhere very far away from where it should be. So I have some code on the website that helps you kind of troubleshoot that. But a quick check using summary shows me I've got all negative, which is good in this case. So then the next biggest hurdle is we need to think about how is our spatial data oriented or projected onto the Earth's surface. And so really, I think this is one of the hardest things about spatial data, if you haven't worked with it before, is we really need to think about what is the sort of underlying data or shape that we're using to represent this in geographic space. So the globe is not a perfect sphere. It isn't flat. I'll just let you know that. But it's not a perfect sphere. And so the datum is really the underlying kind of spheroid or ellipsoid, whatever you want to call it, that fruit shape that often people talk about in orange, right? That we use to represent our geographic space. And if we want to put a point on that fruit-shaped Earth, essentially we could drape, some sort of fabric over that orange, and then draw our points or lines or whatever we're mapping all right on top of that. And so the fabric, think about the fabric as the projection, right? And so it's no matter what, we're trying to take a two-dimensional, a flat thing, and put it over something that's three-dimensional. And so that's where something that's called a coordinate reference system comes into play. And the coordinate reference system, or CRS, which we'll talk about in a minute, is something that really helps your computer in R understand how to sort of convert your data in a way that it can put it on a map. And so there's two sorts of reference systems largely. There's geographic coordinate systems and projected coordinate systems. And a geographic coordinate system is essentially the largely latitude and longitude data, right? And so it's a way to map a place in space anywhere on the globe, which is great. However, it's not so great when you're trying to measure things. Lat-long doesn't do a great job with that. And so folks have come up with sort of an alternative, which is this projected coordinate system, which essentially converts that three-dimensional shape into a two-dimensional grid and a flat surface. And so that's where we can take those lat-long points and plot them on a flat space, and then do our measurements, however those things are. And depending on where we are working in the world, there are different coordinate reference systems for pretty much anywhere, and for lots of different purposes. They have all kinds of different interesting properties. And so California has its own things. There's federal and state sort of designations for these. So I don't really have time to go into all of them, but there are some good references on the website. And so one of the things that I want to talk about is essentially like, how do we make sure we have a coordinate reference system that works? But I will say one of the big hurdles is getting data in with the right coordinate reference system. Sometimes that is really tricky if you don't know what it is. And so there's a little bit of guesswork that can happen. So I would just sort of word to the wise that that's something you might run into. So enough talking, let's make a map. So first off, we would need to make that SF object that I was talking about, right? And so to do that, we are gonna assign something here to our environment. So we'll call it df_SF. And then the SF package, pretty much every function in the SF package starts with st_. And st_ is, there's lots of different functions. There's no way I could go into all of them, but the SF website is excellent. They've got a lot of really good support and some nice tutorials to work through things. For our purposes, we already have our data here, and we want to make it into a simple features data frame. And so that function is st_as_sf. So we're sort of saying, take this thing and make it into an SF object. And that thing in this case, is our CSCI sites match. And then the arguments within this function, so the function again is the st as sf. If I hit tab, it will show me any additional arguments to this function, which there are quite a few. In our case, we largely want the coords. We need to tell it what column the geographic information is in. And so coordinates, you can use either the name of the column. So in this case, long lat. So we want to make sure it's X, Y, right? So long is first because it's X. Or we can also use, in this case, you can also use the actual number of the column. And so if we wanted to use that, it might look something more like 10. You could count down here and count what number column it is, or you could use this option, names CSCI sites match. If I run that line, it actually will print out, hopefully you can see it down here. Let me move it up a little bit. There we go. So you can see it starts with 1 here, and it doesn't print a number for every one, but 7 is sort of wrapping around. So 1, 2, 3, 4, 5, 6, and then 7 is CSCI, and then 8, and then 9 and 10. So that's another way you could look and find out what the column number is. Okay, so in this case, it'd be 10 and 9. But the other thing we want to add is remove equals false. And the reason being is we don't want to remove the actual original data because that might be handy and it might be something that people are interested in a table or in a map or something like that. So we want to keep that information. And then finally, we need to give it the CRS. This is potentially one of the most important parts. And in this case, I know because I've worked with this data, but the CRS is a number, 4326. And I'm going to show you that there are ways that you can look this stuff up. So hang on one second, and I'll show you where I got that number and how you might be able to look it up. And we'll make sure that this is in the chat as well at some point. So here we go. I'm going to move this over here. So this site, spatialreference.org, is super handy, and you can type in anything. So the home screen is this, and one of the first things you'll see is 4326. Okay, and so if I click on that, it will bring this up, and it says that WGS84, which is the most common, that's what Google Maps uses. That's what everything uses for mapping sort of platforms on the web. Largely, it's WGS84. It's always lat long. Gives us a whole bunch of information here in different formats, should we want it, okay? You can look around and play on here as much as you want. It's a really helpful resource to look up that CRS code, which is ultimately, it's either EPSG, which is in sort of ArcGIS world. EPSG is often what is used, but CRS is just this 4, or sometimes it's a 5 or 6 digit number that we want that's associated with a projection, okay? So I'm going to go ahead and close that, and then let's run this and see what we get. Okay. All right, so now in our environment over here, we should have df_sf. And if I hover over this, I'll see something that pops up. It says df_sf, and then it says SF, which means it's now an SF type of data, which is great. But if I were to look at this, if I click on this blue arrow, you'll notice now at the end it has this geometry column, SFC point, with a bunch of other information. And so it's added, again, this is the sticky geometry column. And another way we can do is if we double click, or actually I think just single click this right here, it will open up the view window so we can take a look at this. If I scroll over, what you'll see is geometry, and it actually includes both the lat and long information in here. Now with a polygon, what's interesting is it will also include a geometry column, and it'll stick it all inside that same sort of combined. It'll have a ton of numbers, basically every little point to draw that line or polygon. but it's all in one column, which makes it really easy to work with. Okay, so awesome. Okay, so now we've got our spatial data. Let's do a really quick thing where maybe we want to transform this information into a different coordinate reference system. Because lat long is good, but again, it's not great for measurement and for analysis. We might want to be in something that's a little more functional, typically like UTM, metric, something like that. And so we want to change that CRS. We use ST transform. Again, ST for everything SF starts with ST underscore. And we want to assign this a new thing. We'll call it Albers, because this is a projection that's common in California. And it's we'll see in a second. So ST transform and the data set that I just had created, and then CRS. And in this case, I'm going to use a code 3310. Don't expect everybody to remember this, but let's run this and then we'll take a look, because I think this is kind of the cool part of how easy it is to move between data. This is something often in if you have experience in GIS, can take a little bit of time to sort of translate this data. And what's cool is we can do that really quickly now using R. And so if we want to compare these two things, we can look at what a CRS is for a given data set with ST underscore CRS, DF, SF, and it brings up a whole ton of information. The main thing I want to point out is at the top, it says what the reference system is, and you'll see this EPSG 4326, geographic CRS, so that's that geographic coordinate reference system, WGS 84, it gives you the datum, sort of the shape of the sphere of our Earth, and a bunch of other information, including the units, which in this case are degrees, right? Latin long are degrees. What if we did the same thing for our mystery 3310 CRS? Okay, so now if we look, turns out has some additional information. There's the number. Now it says that now we're in a projected coordinate reference system, not a geographic one. And so it's NAD 83. It has a whole bunch of other information, but notice the unit is a meter now. So now we're actually, this is the part where we've sort of converted our 3D globe into a two-dimensional grid. And that means that when we're measuring things, it's much more accurate and it's a little easier to work with. But it has sort of an origin, and that's where all this other information is sort of translating from that three-dimensional thing to something's two-dimensional. It needs it to tie it back in space to that original globe, right? Okay, so any questions on this? This is kind of, I would say, one of the trickier things about working with spatial data is understanding projections. So I completely feel you if you're like, I have no idea what you just said. So that's okay. The more we work with different data, I think the easier it gets. Okay, I'm gonna go ahead and move forward. All right, so let's read in a spatial file now. Let's read in a shape file. I'm making a new section again with Control-Shift-R. Read in a shape file. Okay, so this is like one of the more common types, and unfortunately it's proprietary to Esri or ArcGIS, but it's used everywhere. And the downside is that it's becoming a bit dated, actually. Folks are moving away from it for a number of reasons, primarily because if you've downloaded this data, by the way, if you haven't gotten the data that I'm gonna show you right now, I'll show you how to grab it in a second, but this data is actually sort of keeps each different component, like the projection, the attributes, the actual spatial stuff, all in different files. So a single shape file, when we think about it, could actually could be like 5 or 7 different files that you need all of them together. And so essentially it's folks are trying to move away from it, but it's so common that it's really important to know how to work with it. And so I'm going to show you how to read it in, because I would say predominantly that's something that you will work with if you're doing spatial stuff. So under resources, you can go over to the lesson data sets, and under spatial data, it has all the information, all the info that we're gonna want. And so if I click on the zipped folder here, it's gonna download this to my downloads. I'm gonna open that up. Hang on 1 second so you can see it. Okay, so now I have this zipped file. I'm gonna unzip that first, okay? And okay, there it goes. Then I'm gonna open that, and now I've got, you're looking at, so there's a number of different things in here. So if I sort this by kind, what you'll see is these are all part of the same file. So this is what I was talking about. There's shape, proj, dbf, shx. That's the shape file. These other two are two different types of spatial files we'll talk about in a second. But either way, what I'd like you all to do is to drag this data into your data folder. So download and make it appear. So I'm gonna go to more, my files tab, and show folder a new window. And great, so now I have, this is where my R project data folder is, and this is where the stuff I just downloaded. And I'm gonna drag and drop that stuff over to there, okay? So green, green check if you have that sorted out, please. And I'm gonna take a pause here and wait for folks to have that as we move forward. And I have a little one at home, so. I see some green checks. I want to make sure everybody has that data. If you already had it, great. Go ahead and put a green check in there. Awesome. All right. Seeing a lot of green checks for the most part. If not, again, we will try to help you out. You know, ping one of the helpers or let us know. And you know, we're recording this, so you can always come back to this. Okay. All right. So let's read in our shapefile now. So now we have our data. And what's really cool, again, SF is so powerful because it can play with all these different kinds of data really easily, which I think is one of the great things about it. And so for our cases, we're gonna read in the states data set. ST-read there's two different ways to read in data, and I'll show you both. ST-read is kind of the default. It's gonna want asks for DSN and layer. DSN is essentially the path or the file. Okay, so if I do DSN and then data and hit tab, there's my data folder, I hit enter there, hit tab again. And now if I scroll down, there's a whole bunch of files in here. We've got a lot of info now. I want to find the one that ends with .shp, .shape. There's all these other ones too, but the shape one is the one that it needs. That's kind of like the master main file that it uses to sort of find all the other ones, okay? So once I have that, I can specify a few other things that might be useful. Strings as factors. We haven't talked about this all that much, but in particular, factors are great, but they can also be really frustrating. And so the default typically in the tidyverse is to read in things as character first, and then you can assign it as a factor. In the R world in general, it's sort of mixed, but a lot of times things will get converted to factors, whether you want them to or not. And there's some issues with that. So the default here is we want to make that false. And we can follow up on that a little bit later. The other thing we want to do is say as tibble, which you may have seen. There's some questions that were in the chat earlier, like what is a tibble? A tibble is a data frame, but it's sort of the tidyverse version. Okay, so it's essentially just a table. It's a data frame. But there's some additional perks to using the tibbles. and they're a little easier to work with for a number of things. So that's kind of the default that I like to go for. Okay, so now we have, this is our all we need. Let's say specify the dot shape, and then we're gonna run that. And now you're gonna see that SF spits out a whole bunch of information here, which is actually quite handy. So it says here that it's read states boundaries from this data, that it's using this driver. So that's kind of like the underlying interpreter of the file, which is as a reshape file. And that the collection has 3 features, 12 fields. Notice it also brings in the geographic CRS automatically, which is awesome. So shapefiles have that usually associated with them, which is one thing that's nice. So we don't need to convert that or do anything. It already has that information. And in fact, if we check stcrs and we do states, we can see that that's, there you go, the CRS. All right, cool. So now let's pull in counties. Let's do the same thing. I'm going to skip through to do counties because I do want to get to a point where we can actually make a map. Counties, stread, same thing here. I'm going to give the data path. And in this case, let's use the GeoJSON. So this is another type of data, right? And we can do the strings as, and actually, sorry, for this one, let's do read SF, because I wanted to show you this other option, because then you don't have to, the defaults already include essentially these things. So it's a little bit shorter, which is nice. The other thing it will do is it will not print out any information. It's quiet, so which may or may not be helpful. But now in our environment, we should have counties, and we've got states. Okay, cool. All right, so let's make a map. Thank you for your patience. We're there, we're getting there. I'll definitely get to a couple other pieces to make sure that we have that. So plot, the base thing that we can do is plot, and let's plot our points first. Let's make a section. Okay, so plot df sf is our, remember our CSCI data. If I just plot like this, and I hit enter, what you're gonna see show up is a lot of maps with lots of cool colors. This is the Viridis palette here. This is cool, but maybe not useful. And the reason is it's plotting actually for each single column in my data, it's making a different map. One of the ways around this is we just want to plot the geometry. We don't really want to get all the underlying data yet. And so we can use the $ here to specify the column. And in that case, we want geometry. Okay. And so plot geometry. Now we have just our spatial data, just the spatial part. Okay. And then, sorry, kids and dogs are, I don't know what's happening in the background right now. It's awesome. Okay, that's that part. Let's jump to, let's make this plot a little bit fancier. We haven't talked about this, but in base plot, these things apply whether using spatial data or not. So a lot of the little tweaks that I'm going to add here would work in a normal plot of a data frame. So that's the nice thing, is once you learn this, you can use it for all kinds of different stuff. So one of the things you can do, let's change the point shape. So point character is PCH. And one thing we haven't done a whole lot is this help tab over here actually has a whole lot of information. And so if you were to type PCH and hit enter, it's thinking. Maybe. Nope. Maybe I try this, PCH. Maybe in the wrong place. Aha, there we go. So it brings this up. And this is really handy because there's a whole, if we scroll down to the bottom here, we'll see there's a whole rubric for all these different shapes that are different points. And so if I want to specify a point, what I can do is I can actually look on here and say, okay, let's make squares, and I'll do 15. So point character is equal to 15, okay? And then I can also, let's change the color and say, let's use an if-else statement, which Haley demonstrated earlier. Now we can actually start using our data in a way that's pretty cool. So we can actually look at the threshold for the CSCI score itself. So CSCI score is the bioassessment score. And we can say anything over 0.75, which is sort of a metric rubric for the stream health or alteration. Anything over 0.75 is something we might be interested in. It's indicating it's better. And let's say that we want to make that color purple. Okay. Otherwise, we want to make that color gold. Okay. So if it's over 0.75, it's going to make that purple. If not, it's going to make that color. And actually, I need to take, sorry, this color out. There we go. Okay. And then let's add a different sizing. So CEX is a way to change the size of your points. It's kind of like a multiplier. And then we can make our labels, which is a really common thing you want to add. Okay, let's run that. And whoa, that is crazy. It's a fun little plot. You can hit zoom. You can zoom in on that, and we can kind of see what we've got. So probably not, the best plot that we've ever made, but it's a start, which is great. So let's jump in, and I want to show. I'm sort of jumping ahead here. Let's make sure we have the library map view loaded, because I think this is one of the coolest packages to play with, and I want to make sure that we have time to play with it a little bit. So map view, I think we loaded it earlier. I'm going to do it again. I'm going to make a section, map view maps. So this is a really handy package for all kinds of things. I use it all the time to sort of just quickly explore my data. And I'll show you why, because it's pretty easy to use. So map view is the function, and I literally give it df_sf. So you give it, as long as your data is an SF object, which this is, I can now plot this in a really dynamic and interactive map. So I ran that, and suddenly I have like a much nicer map than I just made. And even better, I can zoom in on this, and I can click on one of these points. And this is the great thing. You can look at all the underlying attributes of your data for this. You can change the layers here. The default layers are great. They've got sort of street maps, topo. So if we were to zoom in really close, we can really get the topo layers. This is a really handy package. If you can't get it working, please let us know. It's definitely worth having and using. The other advantage is you can click this little button up here, and it will pop out into a web browser, whatever your default browser is, Chrome or Safari. One issue that's been happening lately is this, where your points don't show up. I think, let me double check this. The workaround for this, which I was meaning to add, there's a map view options here. And I think the thing that I want to do is, where is it? Hang on one second, I will. Locate it. There's one little bit of tiny code that's kind of annoying, but seems to fix this. It's a known issue, and they are working on it. You should be able to interpret it. So actually, green checks if you were able to do this and you see a map with all the points and you can make it work. If not, put a red check, please. Where is it? oh, here it is, FGB, false. And I don't know why, I don't know what this does specifically, but it seems to, now if I rerun this, now if I click on this button again, aha, it works. There you go. So I don't know if that was an issue when you were looking at your data, but that seems to work for me. Again, so what's really great is you can save this data right out of your screen here, typically using the export button and save as web page. If I click on that, I can make a, call this a CSCI map. And if I save that, and I look in my files, might take a second. Oh, it pops it open. So what's really cool is now I have saved this map, and this works outside of R, right? So this map right here that we just made, you could zip this up and send it to somebody, and they'd be able to see the same data and interact with it, hopefully in the same way. And this is, it gets big with more data. So 2 megabytes, it's reasonable, but just FYI, it can get quite big. Okay, so I'm gonna pause here for a second because we're 10 minutes from the end and I haven't even switched over to one of the lessons. And I wanna check in with everybody. So I've gotten to a few key things. I wanna show a few other SF specific things of working with the data, particularly sort of intersecting, cropping and buffering, which shouldn't take too long. How many of you would be interested? I'm okay with staying a few minutes past the 4:15 sort of deadline we had. We have some time. If folks are okay with that and interested, we can do that. If not, can you please put a red check that you've got to bail out, just so I can kind of get a sense of that. And we can also let helpers kind of follow up with things going on. So green check if you're good with going a little bit past 4:15, red check if no way, Jose, got to bail. And I totally understand. Again, we'll record this and make it all available. Again, to export the map, I went to where it popped up in my viewer tab, and I went to the export button here. And then I clicked this little arrow on the right, and then save as web page. And I'm seeing some errors in the chat that relate to version GDAL type stuff. And so that is somewhat common. So hopefully we can get that troubleshooted. All right, I see mostly green checks, one red X. That sounds great. We'll make sure we record it. So if you do have to head out, totally understand, apologize. Things always take longer in this case, but I do want to show a couple other things. And so just in case we don't get to that point, if you do have time, please go to the tab on the website here under resources. And if you have to head out, please do fill out the short survey. It's like 3 questions. That really helps us adjust this website or this workshop if we do it again, okay? All right, so let's move forward then. And let's use SF to wrangle data. Okay, so sorry, I'm flashing screens all over the place here. I'm gonna go ahead and close this, and I'm gonna move this back over here. Okay, so the next step is essentially to let's think about how we can actually work with this data other than making maps. The map is great, but in more often than not, you're going to have to be sort of cropping down your data or working with your data in a way that requires a few more tools. And SF is really powerful, and I'm barely going to scratch the surface. So I do want everybody to know that the webpage, the SF help webpage, which is linked on the website, has tons of options for spatial operations, buffering, cropping, clip, merge. If you're familiar with any of those and more, there's a lot of options, okay? So what we're gonna show now is how to basically let's do some buffering. and cropping, okay? So one of the things that we have here is we have our counties data set. Let me move this back up so we can all see it. And files. So in our data, we should have a counties data set, right? And that we read that in as counties. We haven't looked at that yet. So let's do a quick map view of counties just to make sure what we're looking at makes sense. Cool. All right, California counties, there you go. That's awesome. But what if we want to intersect that points data that we had, right, this, with a given county? We just want to look at one county and we only want to pull the points from one single county. Well, these are both SF objects, which is nice, but let's filter to pick one county that we're interested in. And in this case, let's use El Dorado County. And I think I call this Eldor CO. Okay, and filter is our dplyr. Again, this is coming from dplyr. And again, this is where the SF is really powerful. We can say counties is our data that we're interested in using. And then the filter that we're interested in, if we look in our environment, counties, and there's a name field. So let's use the name field to filter our data. Name 2 equals instead of 1. 1 equals is for like an argument. 2 equals is for equality or equal to something. El Dorado, and if we run this, we should now have a new object that's 1 observation. So that seems like it worked. 1 county, right? Cool. Let's go ahead and plot that so that we have this. And I'm going to show you how to add layers using the base plot option. Again, we have to specify just the geometry because we don't want it to plot all those different attributes. Okay, so I'm going to plot that. There's our county, great. What if we want to add another layer using this approach? Well, we can use plot again, DFSF geometry. Excuse me. Add is the key bit here. This is what I'm going to basically add this data to the existing map. And I'm going to say, I want the background of my points to be gray. And we'll say point character 21, which is a hollow circle. Okay, there we go. Well, that's interesting. So I've got, remember, this is plotting all the points for California, not just in my county. So what we want to do is we want to crop some points, okay? And to do that, we're going to use another st function, st_function. So let's use, let's call this Eldor points, and st intersection, not intersects, but intersection. And the first thing we're going to add is dfsf, which is the thing we want to crop. And then the second thing is the thing we're cropping by. Okay, so X and Y, this is usually how it works. So first thing's the thing you're cropping, second thing's the thing you're cropping by. And we run that, and we're gonna get this kind of interesting warning. It's okay. It just means that it's saying, hey, this is in lat long, like be aware. You might have some issues if you're trying to use this for like measurement, but it still worked. And so now I can add this layer with plot and dfsf, oops, sorry, what do we call it? Eldor points, okay? And in this case, let's do geometry, and we'll make these points add equal true, make these points purple. Background equals purple. And the point character, again, is 21. There we go. So now we can see we've got this, now we have a set of data that specifically we've sort of cropped it down to something we might work with. This is something that's really common, and you might want to send this to somebody, right? So this is a common thing where you're sort of cropping or buffering. Let's buffer, show you how to do a buffer. It's going to be important with these types of operations to be working in a projected system, not the geographic system. So something that's not lat long. Okay. Plot, oh, sorry. Let's transform. Remember that transform that we had from before? Albers, st transform, and our data, which was the county data. And then the CRS, here's the thing we could do. We could either add that 3310, which was the thing we're interested in, or we could say, we know we want to use this CRS from something that we already have. So I can actually use this st underscore CRS function to pull the CRS from an existing object, which is quite handy sometimes. So we'll do that, because then you know it matches. You know you're pulling the same thing. Cool. All right, so then we can use, let's make a buffer. And county, and we'll make a 5-kilometer buffer, buff 5 km. And for this, st underscore buffer. And here's where the nice thing, where we now have a grid that's a metric, right? It's very easy to specify our buffer this way, because I don't know about you, I definitely don't think in degrees. So converting like degrees to a distance could be really not as easy. So distance equals, so 5 kilometers would be 5,000 meters. This is in meters. And great. And now let's go ahead and add that to our existing, I'm gonna go ahead and add that to our existing plot. Again, notice I'm just adding, you know, this is, the plot command is pretty easy to just add layers, throw layers on. And you can do this similarly with map view as well. Geometry, and let's say border is blue. And color is, this is the inside part. So the border is the outside part, the color is the inside part of a polygon. There we go. Okay. And no, I didn't add the add true to the previous map. Okay, so we have buffered, we've done an intersection. If we wanted to now intersect our points, existing points by this buffer, we could do that. There's a whole bunch of other stuff in SF that I don't even have time to scratch the surface of. But once you have your data in this SF format, it's really helpful. You can do a lot of cool stuff. And then what mainly I want to do now is show you how to save that data out, because I think that is kind of the next important thing, particularly from a spatial side of things. So we've talked about save, right? So I can save this data, and I could save any of these layers that we've talked about. But if I want to write this data out to a shapefile or to something else, let's look at how to do that really quick, okay? Because you know, not everybody uses R, that's the reality. And so I think it's good to know how to share this spatial data with other folks. And so again, the SF has a nice function, stWrite, which allows us to write all kinds of different data. And so I think here we want to write, let's say, our buffer. So the arguments are object is what the thing we want to write. So Eldorado, let's write this buffer out as a shapefile. Eldor buff, long name. Okay, and then what's the next argument? Okay, DSN. Remember, DSN is our data source name, which is essentially the file name or the path. You know, so in this case, DSN is equal to, let's put this in data, and let's call this Eldor, the same exact thing. Buff up 5 kilometers, and then .shp. And this is important because that's how ST or the SF package knows what kind of data to write. I'm going to run this. And you're gonna get some warnings. So warnings are different than errors. So warnings are okay, it still means it worked. But if we look at this, notice what it's saying. It's only writing one feature. So unfortunately, this is one of the downsides of the shapefile format. It can only handle 12, essentially 12 characters in a given attribute field. And so it's saying it had to trim essentially that information down when it saved it as a shapefile. And so if we were actually to read this back in, we'd notice that in our data, so if we look over here at the El Dorado County buffer, you'll notice some of these have longer column names. If we read that back in, you'd notice that these were only 12 characters long. It would have dropped that information, which is not ideal, and that's kind of one of the reasons that folks are trying to move away from shapefiles. So that's how you would save data out, okay? Any questions on that? If we look actually in our data folder, you'll notice now we have, again, it's saved all 4 of the pieces required to make this shapefile. So if you were to send this to somebody, they'd need all 4 of those, right? So I'm gonna pause here really quick. Okay, the SF, I would say website is actually the best place to go. And it's linked in the website as well for more information. And there's a few additional resources as well in the resources tab, okay? Okay, so we've done map view. Oh, I wanna show you how to do map view 2 layers. So we're kind of jumping into the next lesson. If you're following along on the website, the make a map lesson. And I'm gonna show you, let's just use what we've got here to add two different layers of data, and then we'll do a quick ggplot and call it good. And we'll only be a few minutes over. Whirlwind. Okay, map view. Let's map view our, let's do our El Dorado information. So here is our El Dorado points that we cropped. Let's go ahead, and there's a lot of additional options we can add in here, including like the layer name. You can change the color, all kinds of cool stuff. For this, let's just change the layer name to CSCI sites. And I'm gonna plot that. Okay, now you'll notice we have a map, thinking, of just our points for El Dorado. But what if we wanna have also the boundary of the El Dorado County? Well, to do that, we use the ggplot sort of functionality of plus. So sort of adding these maps together. So map view, now I can specify any other data that I want in here. Let's add our buffer. We'll call this buffer, or county buffer. And I'm gonna make the alpha, which is the sort of transparency. And alpha is a really handy thing when you start making a lot of maps to play with, because it can really clean up your map. So alpha regions, because in this case it's a polygon, of 0.5. So alpha ranges from 0 to 1, 1 being completely solid and 0 being completely transparent. Now I'm gonna run that, and there we go. So I've got the underlying buffer and the points all in one map. And I can turn those layers on and off. If I go over to this layer bit, you can actually turn layers on and off. Okay, and you can imagine, these are both blue. That's not ideal. You wanna change the colors. So we could go back into this and say color regions, which is the inside part, right? Say salmon pink, and now it stands out a little bit more. Okay. Thumbs up, so, or yeah, green yes, if you are still currently awake and things are working and you're finding this interesting. Red X if you're done, which is totally understandable. Okay, I have one more thing to show you, and then we're done and open to questions and anything else you have going on. I do want to show the ggplot option to sort of make a static map. Cool, awesome. Thank you, everybody. Really appreciate the patience and feedback. Cool. All right, so let's talk about how to do this in ggplot. That's the one sort of thing I haven't done, and I wish I had more time to do it, but mapping SF in ggplot. For those of you that have no idea what ggplot is, just bear with me. We did some of this yesterday, really briefly. ggplot is its own plotting package in the tidyverse, super powerful, and now it's even better because we can actually use it to map SF objects too. So there's one other package that I want us to make sure we have loaded. We already have the tidyverse, which includes ggplot, but spatial is a really handy package for adding north arrows and scale bars. And so I want to make sure that we have that loaded. Okay. Okay. So again, a ggplot, let's call this nice map. And the structure of ggplot, Haley covered this yesterday, is to call the sort of the framework of the house, right? The structure, the bones of the house is in this general ggplot. We have to say we're making a ggplot. And then everything after this is added with a plus and a new line. So I'm gonna add a new line here. So I have here's my foundation, my plot. Now, remember there's geoms and there's a whole bunch of geoms here. If you kind of hit tab and see, there's a bajillion. But the one we're interested in is called handily geom_SF. And you'll notice there's label, text, a whole bunch of other stuff you can do. And so the great thing is this plays really natively, helpfully with our data, our actual, and you know what? I don't think I read in, that's right, we're kind of skipping around. So we'll just, there'll be a map you can make on the website following that, and there'll be a map from our code here today. So you'll get extra practice. But let's just make a map of our points from the county. And so data is going to be L door, let's do the Albers. Okay. And let's then also have our color. This is going to be the border, the boundaries. So I want it to be kind of big. So I'm going to make color gray and line width wide. So I think the default is like 1 or less than 1. All right, so there's one layer of our map. Now with ggplot, the important thing to note is layer order matters. So if I were to put my points first and then put this county next, the points would be underneath the county, which is not necessarily ideal. I want the points on top where they're easy to see. So we're doing the county first, and then add a plus and a new line. And now I'm going to add my points. Okay, so let's do, oops, sorry, geom. Again, we can use, I'm going to just say, show you how to do geom SF, but we could do this as long as it's an SF object. We can, did we trim? Yep, Eldorado points. Okay, so data equals Eldor points. Okay, and in this case, I want to make them kind of stand out. So I'm going to make them orange. The fill is orange. And remember that point character, PCH 21. That's that hollow circle. Okay. Cool. All right. So then we've got that. What is next? So we want to see now, and in fact, let's add an alpha. It's one thing I mentioned because I think that's helpful. Alpha equals 0.7, just a little bit, so they kind of stand out. And then now the final bit, which is the GG spatial part, which is handy, add a scale bar and a north arrow, which is always something a map should have. And in this case, GG spatial has this thing called annotation. And it will say down here, it has all kinds of different options. In this case, I want a scale. And I'm just going to use the defaults. There's lots of ways you can tweak this to make it look fancy. And I'm going to add a north arrow. There we go. And you can actually change the location of the north arrow. So you can use location. Let's try top right, but I think there's like bottom left. It's any of these combinations. And then finally, in ggplot, there's a lot of things you can do. One thing that is really helpful is the labeling. So if we want to change the X and Y label, we can say this is long, Y is equal to lat. We could add a title in here. Simple map. And then we can, there's a whole bunch of themes, which I will let you play with. It's quite fun and addictive. The theme BW is black and white. I think we'll keep it like that for now. All right, so we've made all these layers, right? Again, these are layered. The order does matter. Now I ran that code, and notice one thing: if you put your cursor anywhere inside a ggplot and hit Command or Control Enter, it will run the whole chunk, which is kind of handy. So it's running, I'm putting it in different places, and it's running the whole chunk, but nothing's happening. Well, that's because we assigned it to nice map, and so if we want to see the map, we need to run that nice map, and it's going to take a second. And hopefully not break. And there we go. It's not pretty, but it works. So now we have a map that has a scale bar. It's got a north arrow. This is, you know, the startings of something that you could actually, again, save this out and send to somebody, include in a report, all kinds of different stuff, right? So I'm going to stop there because we're 15 minutes over, and I do want to respect everybody's time. And I think my voice is starting to go anyway. So let's circle back to, I'm gonna go ahead and stop. Actually, I'm going to save this, and then I'm gonna go back to the website, and I would really like everybody, please, to take some time, ask some questions, follow up. But if you go to the resources tab and feedback and click on this short survey here, please let us know what you thought of the workshop. And I would also encourage you, if you can, donate, because this is all the helpers here have been donating their time. The generation of all this content was freely done. And so these sorts of events really rely on making sure that the SFS and CABW folks have some funding for scholarships and other things. So we didn't make it mandatory, but if you can chip in, you know, 10, 20 bucks, it makes a big difference. So I just want to reiterate that and say thank you, and sorry we ran late. Haley, do you have anything to add?
Nope, I don't think so. Please give us feedback. It's really helpful in designing the workshops for future iterations. And also feel free to contact us after the fact. So if you're trying to work through the rest of this yourself and want to get in touch